Welcome, this is lesson 17. In this tutorial, we'll be talking about the Mac status model. You can find the very code at projectfpga.com/tcp select Mac Status Subcircuit. So what is this Mac status? Actually, this Mac status gives a record of the status of our receiver and transmitter. Most of the signals generated here are going to be used in our wishbone. They're going to be used when we'll be talking about the wishbone. The wishbone protocol is our upper layer protocol. So most of the signals we are going to be generated there will be used there. So we can see some signals we've treated before, though like I said, most will be treated when we'll be talking about the wishbone, but we've seen signals like the receive end. We've done it before. We are going to talk about them. Then we've also seen this receive packet too big. Then we've seen our retry limit, and then I'm going to also show you about this carrier sense loss. Let's talk about this carrier sense loss. When does this signal come on? So carrier sense loss signifies that the line is idle. That is, after there was a carrier sense. That is, when the line is busy, the carrier sense signal comes on. This carrier sense signal here comes on to tell you that the carrier is busy. But whenever it's idle, that is, it was busy before and then later it becomes idle, then this carrier sense loss comes on. So let's see how it's turned on. So first says this OR gate says it must be in either of the two, either state data 1 or state data 0. Then this big AND gate 1, it must not be in full duplex mode. Let's see this, right? Because in full duplex mode is transmitting and receiving at the same time. So at that stage it's not going to, you cannot say that the carrier is busy, because it's receiving, then it can still transmit. So when it's not in full duplex mode is when we can talk about the carrier being busy. Then also the carrier sense, there will no longer be carrier sense. Yes, we talked about that. And then again, there will be no collision. See here, no collision. Then the last one, this loop back. We are going to talk about this loop back when we will be talking about the whole Ethernet core as a whole. We're going to see how we generate this loop back. So whenever this situation is met, the carrier sense loss is going to come on. And then if for any reason at the beginning of data transmission you reset it, at the beginning of every data transmission is being reset. So let's see, assume you are in state data 1 and I decide to clock this, you see it's on. So you have to be in either of the states for you to know if the carrier is idle or not. So we've talked about this retry limit. We saw it when we were talking about the ETH random, because in the ETH random we have what we call the retry count. Whenever there is a collision, the retry count keeps increasing. It keeps increasing. So here is now saying when maximum collision has occurred, turn on this retry limit. So that is what is here. Whenever the maximum collision signal is on and you are at the end of the transmission, that is start TS zone or start TS abort, you should turn on this retry limit signal. All these signals we are going to use them when we'll be talking about the wishbone. Then the receive packet too big, and so on and so forth. Then also you can see this short frame. So what comes about this short frame? That is when you didn't enable the frame checksum, the CLC enable, and you didn't enable padding, and then again lastly your sent data is not up to size. This short frame comes on. It means that the packet is going to be discarded. That is when the received data didn't meet this requirement. When the size of the received data is very small, that is when this short frame turns on. So let's look at it more. What turns it on? Short frame. We're talking about this short frame. So see, it's comparing the hours byte count and the minimum frame length. Is it up to the size? If it's not up to the size, it means the short frame is going to come on. So you see, when it's less than the size, this short frame is going to come on. And let's see what turns on the multiplexer here. Okay, you can see. So we're still going to come back to this Mac status when we'll be talking about the wishbone. So at that point we are going to see how each and every one of these signals are being used. Every one of these signals, they are used when we'll be talking about the wishbone. So at that point we'll see how they are being implemented, how they are being used. So we've talked about some of them. Like this is the receive end. We use this receive end when we are talking about the receive control. So this receive end symbolizes that yes, data have finished sending. We are at the beginning of the reception of new data. That is, this receive end turns on the detection window in our receive control. So that is that. Then the loadrs status, this bit actually turns on most of this signal here, because when most of these signals are being loaded is when the loadrs status is on. Let me highlight it and you see that it went into most of the signals. So most of these signals get latched when this loadrs status is on. So let's see what this loadrs status is. You can see here the big O. So let's talk about one of them. One of them says so this loadrs status, we can see how it comes on. So it says we have to be in either of the states. We have to be in either of the states, and the MRSDV is not valid at that point. And then lastly, the RS byte count is greater than 2. So when we'll be dealing with the wishbone, we're going to come back here and see how each of these signals turns on one after the other. Please go through the code. It's very self-explanatory. Go through the code. It's very self-explanatory. Then by the time we'll be talking about the wishbone, we're going to come back here and treat each of these signals one after the other. Thank you, and kindly subscribe to this channel.